Alright, hi everyone. Welcome to our next chapter, which is on anti-differentiation. Now, as the name suggests, it is just the opposite of differentiation. It's just going backwards. But because the word anti-differentiation is a little bit of a mouthful, sometimes people end up referring to it as integration. There is a very slight difference between anti-differentiation and integration, but I'll explain that when we get to it. So, going backwards for differentiation is anti-differentiating. So we can write that down using symbols. We can say that, well, to go forwards is doing the derivative, the dy dx thing, of a function, f of x. And if you do that, you'll get the derivative function f dash of x. So for anti-differentiation, we want to go backwards instead. We want to start at the derivative and get back to the original function. And here are the symbols we use to show that. So we say the antiderivative of f dash of x with respect to x, so we say dx, equals f of x. Okay, so the new symbols in particular are this one, the anti-differentiation symbol, and saying dx with respect to x. Just to be extra confusing, sometimes people use different symbols. Sometimes they say to do the integral of some function with respect to x, dx, is equal to a big capital function of x. So here it's the same thing, it's just a different symbol. So they've chosen to use the function here to be the thing you're integrating. In which case, big F is the integrand. It's the original function. Okay, so let's just do a couple of them. Let's do a couple of them for examples, and you'll discover that it's pretty straightforward, I think. So first off, let's start with differentiating something. So d of dx of 2x cubed plus 6x. So this is differentiating first. Will give us, so we multiply the 3 by the 2, giving us a 6. Keep the x and take 1 off the 3, gives us a 2. And then we add that to differentiating 6x. There's a secret 1 up here, so it's 6 times 1, 6. Take 1 away from 1, gives 0, so it's just 6. So we go, we've differentiated, we've gone forwards. So we've done this bit here, and next up we want to go backwards, we want to integrate. So if we want to integrate our answer of 6x squared plus 6 with respect to x, we have to go backwards. We have to say, well, the first thing I notice is here we've got an x to the power 2, so obviously that has to become an x to the power 3. Then if we had been going forwards, this 3 would have multiplied by whatever's here to get 6. In other words, what needs to go here is 6 divided by this 3. 6 divided by that 3. And so obviously that bit is going to be a 2x cubed there. Now similar thinking for this constant term, we've got a 6. And so the only way you can get a constant is by being multiplied just by x. So I can do it plus 6x plus 6x. So there we go, and I've got back to our original answer, just using sort of backwards thinking in reverse. Now, this is a bit of a simple example. There's some complicated things that can start happening, which I will illustrate in the next 2 examples. Okay, so let's start off by first doing a few derivatives. So first go forwards, we'll do dx of 6x squared plus 2. So that one will become 2 times 6 is 12, and then we'll have an x because it takes away 1, and plus 2, so that disappears. Okay, so there we go, the derivative of this is 12x. So now if I do the the antiderivative of 12x with respect to x, well, that would give me, okay, so there's a 1 there, so I know that it has to be an x2. The only way you get a 2 there is if 2 times whatever goes out the front, the coefficient, gives 12. So it's 12 divided by 2 gives me a 6 there. And there's nothing else there, so I'll just leave it at that. Okay, some of you, if you're paying very close attention, you'll know there should be a plus 2 there, but we have no way of getting that plus 2 just yet. So I can't write that in just yet. Alright, now here is a second example. If we want to do the derivative of 6x squared minus 5. Okay, so let's give that one a shot. It will look like this. It will differentiate to get 12x, and the 5 disappears. So there we go. Now we'll do the opposite, the antiderivative of 12x dx. Well, we notice it's actually the exact same as what we had before, so it is 6x squared. So our answers are the same, but our original function is not the same. Okay, these bits here are not the same as each other. So somewhere we've forgotten something. And that is, we need to always add in a constant term, plus c, for an unknown constant, plus c. Okay, because if there is a constant term and you differentiate, it disappears. This plus 2, it disappeared. This minus 5, it disappeared. Nothing there. So our answers are actually 6x squared plus c and 6x squared plus c. And it just so happens that our constants are different in each case. In this first case, c is equal to 2, and in our second case, c is equal to minus 5. Okay, so the real challenge here is actually figuring out what that constant term is. We need to know how can we get the c equals 2 bit. And I'll show you that in the next example. Okay, so what we're really interested in is finding the constant term. Okay, so here's our question. It is find f of x, our function, if f dash of x, our derivative, is equal to 6x and our function at 0, when x is 0, is equal to 7. Okay, so we're finding our original function if our derivative function is 6x and our original function at x is 7. So what we're doing here to get from the derivative back to our original function, we need to anti-differentiate. So we're anti-differentiating 6x dx. So first off, we know there must be, here was a 1, so that needs to be higher for the integral, the antiderivative. And the number that must go here has to be a 3, because 2 times 3 gives 6. And now we need to make sure we add on our constant term. So it's 3x squared plus c, our constant term. Alright, so now what we have to do is figure out what our constant term actually is. So far we've got our original function is 3x squared plus c. And this is where we use our extra piece of information. We know that our function at 0 is equal to 7. So our function at 0, that is 0 squared plus c, is equal to 7. So 0 squared is 0, 3 times 0, that's 0, plus c equals 7. So here c is equal to 7. And so I can write out a full original function. F of x is 3x squared plus 7. So that's using this bit here, 3x squared plus c, and c is 7. So there we go, that's our final answer. Okay, let me do one more to tie everything together. So, this time I'll use different notation. I'll say antidifferentiate f dash of x equals 2x minus 3, given that our original function is, given that, let me say that again, our original function at x equals 1 is 6. So we're anti-differentiating this thing here, given that our original function at 1 is 6. So let's set that up. We're going to integrate, or anti-differentiate 2x minus 3 dx, because with respect to x. And that will give us, so there's a 1 there currently, so that'll become next to the 2. 2 divided by 2 is 1, so we don't need to write anything there, because 2 times 1 will give us that. And then it's a constant, so that'll be a 3x. And lastly, can't forget our constant term plus c. So there we go, that's our function, f of x, equals that. So now we use our extra piece of information. Where are we here? So here we go, our function at when x is 1, so that's 1 squared minus 3 times 1 plus c equals 6. Let's tidy that up. 1 squared is 1, minus 3 times 1 is minus 3, plus c equals 6. 1 take away 3 is minus 2, plus c equals 6. Now I'll add 2 to both sides to get c equals 8. So our final answer, f of x equals 2, starting that up, is x squared minus 3x plus 8. And there you have it. That is all there is to anti-differentiating. First you just do the backwards thing for differentiation, and then you add a constant and find out what that constant is. Now last thing I should say is, what is the deal exactly with the constant? So let's think back to our examples back here, where we had the same answer because we hadn't yet found the constant. That is a bit like this example here. Okay, so imagine this was our final answer. Our final answer was 2x cubed plus c. So that one, let's make that a c. So here's c is just 0 at the moment. So depending on what that constant is, it will just shift this graph up or down. So let's have a look. Here it is shifting up and back down. So all these different curves actually have the same gradient function, because the slope of this line doesn't matter. It doesn't depend on how high up it is. It just depends on the slope, on the gradient. So all these different curves, like this one here, and the constant is 2, or this one here where the constant is 3, all these different curves, we call those a family of curves, and all of those are valid answers if we don't get extra information that allows you to find the constant term. So there you go, that is anti-differentiation for you. So good luck and have a go at 10A and 10B.